You know, sometimes I wonder if you stood outside on a quiet night, just you and the cool air of late evening, and looked up at that pale blur in the sky, would you feel it? That faint smear of light that has traveled across millions of years to reach your eyes. Would you sense that it is not just a distant glow, but an entire galaxy, a vast archipelago of suns drifting toward us across the deep? And, perhaps more importantly, would you feel how small and yet how deeply connected we are to it? The Andromeda Galaxy, you see, is like a doorway hanging gently in the dark, an invitation to step beyond the familiar and into something older, quieter, and far grander than anything we know here on Earth. And that's the thing. Even though it lies millions of light years away, it has always been part of our story, a silent companion shimmering at the edge of human curiosity. I suppose what I'm really asking is this. When you gaze at Andromeda, do you imagine the trillions of stars, the drifting clouds of dust, the ghostly rings and ancient collisions that shaped it? Do you imagine the possibility that somewhere, on one of its unseen worlds, someone else might be looking back, wondering about us? Well, tonight, as we settle into this slow and gentle journey together, let that thought rest with you like a soft light. Time is not a clock, after all. It's a landscape we travel through. And out there in that landscape, Andromeda waits like a distant memory of a universe still growing, still becoming. Before we go on, I'd like to ask you to subscribe to the channel and leave a like. My aim here is simple, to help you drift off to sleep while exploring the wonders of science. Where are you on the map? Let me know where you are in the world and what time it is in the comments. It's always fascinating to see who's joining us from all around the world, so let's continue. Well, you see, when we begin to talk about Andromeda, there is always this quiet pause inside me, as if the mind itself needs a moment to stretch before stepping into something so immense. Andromeda is often introduced as the nearest large spiral galaxy to our own, but that simple fact does little to capture the strangeness of standing beneath the night sky and realizing that your eyes, these small biological instruments shaped by Earth's sunlight, can actually see it. Without a telescope, without any technological help, you can look up and witness an object so far away that its light began traveling toward us long before any human stories existed. And that always leaves me a little breathless. You know, we tend to think of galaxies as illustrations in textbooks, as tidy spirals with arms curling gracefully around a bright center. But when you think about Andromeda as a real place, a place with its own vastness and depth, it becomes something else entirely. It becomes a city of stars, a shimmering continent of light, a gravitational symphony billions of years in the making. It becomes, in a way, a mirror held up to remind us how young and small our own Milky Way really is. According to the outline you shared, Andromeda contains not millions but trillions of stars. And that number alone feels like a tide washing over the imagination. Trillions. Each one with its own story, its own brightness, its own potential worlds. And we, drifting here in our little corner of the Milky Way, are close enough to watch it with the naked eye. Perhaps what fascinates me most is the thought that Andromeda is part of the local group, a small gravitational family of galaxies bound together in a slow cosmic dance. There is something comforting about that, like knowing that even on the largest scales, the universe arranges itself into communities. Galaxies tug on one another, influence one another, drift toward one another across unimaginable distances. Even at that scale, nothing is completely alone. Andromeda, larger and more massive than the Milky Way, occupies a kind of elder position in that group, as though it has been watching over this corner of the cosmos long before Earth cooled enough to host oceans. And when we say Andromeda is the most distant object visible to the human eye, it invites a rather curious question. What does it mean that our earliest ancestors, hunters and wanderers, with no knowledge of galaxies or cosmic distances, could still look up and see that faint patch of light. They had no context for it, no word for galaxy, no sense that the sky was filled with islands of stars. Yet the light of Andromeda still touched them. Perhaps it flickered through the branches while they rested by a fire. Perhaps it hung above deserts, above forests, above the first carved stones and whispered myths. This connection across time feels oddly intimate, like a thread weaving all of human history to a single distant glow. Andromeda, you see, was once thought to be just a nebula, a cloud of something inside our own galaxy. It took Edwin Hubble to show that it was, in fact, a whole separate galaxy, a revelation that cracked open the human understanding of the universe and expanded it beyond anything we'd previously imagined. But that idea, the idea of Andromeda being something far beyond us, had been waiting in the sky all along. All those years, all those human generations, stargazers simply didn't know what they were looking at. They sensed mystery, but not scale, beauty, but not immensity. And that feeling remains, doesn't it? Even now, in a world of satellites and modern instruments, Andromeda still feels like a whisper from the deep universe. And well, I suppose if we were to drift inside it in our minds, to float gently along its spiral arms, we would find a galaxy with far more structure and complexity than its soft appearance suggests. The stars you see with your unaided eye are only the brightest handful, but behind them lies a staggering depth of star clusters, gas clouds, ancient relics from galaxies that Andromeda has pulled apart and absorbed. Because Andromeda is not just large, it is active, restless, shaped by countless interactions. Sometimes I think of it as a great cosmic library, each star and cloud holding a chapter of the universe's long story. Even the halo surrounding Andromeda is immense, far bigger than our own, extending outward like a ghostly shell of ancient stars and dark matter. And if you imagine that halo shimmering faintly in the dark, wrapping the galaxy in a kind of pale cocoon, it begins to feel almost like a living organism, breathing in its slow, cosmic rhythm. These halos tell us about collisions long past, about galaxies drawn in and torn apart, their stars scattered into a faint sphere that glows around the whole structure. That halo is the memory of Andromeda, a memory written not in words, but in starlight spread thin. Andromeda's mass, its scale, its layers upon layers of structure, all hint at a galaxy much older and more seasoned than our own. When we say it is larger than the Milky Way, what we are really saying is that it has gathered more stories, more remnants of cosmic events, more scars of creation. And in a way, looking at Andromeda is like looking at a future version of our galaxy, as though peering into a kind of cosmic time mirror. The spiral arms, streaked with dust and lit by young blue stars, are regions where new beginnings continue to unfold, even as older stars drift slowly toward their quiet end. You see, galaxies are not static. They are ecosystems, constantly renewing themselves, constantly rewriting the balance between chaos and order. But there is something else that always lingers in the back of my mind when talking about Andromeda. It is the simple fact that light from this galaxy takes 2.5 million years to reach us. The Andromeda you see tonight in 2025 is not the Andromeda of today. It is the Andromeda of a world where early humans had not yet spoken their first words. It is a message sent across time, across eras of ice and climate shifts and migrations, arriving gently at our retinas only now. And in that realization, time becomes something far less rigid than the clocks we live by. Time becomes a river, and we are simply catching signals drifting along its current. And if you imagine that journey of light, leaving a star in Andromeda before the first human hands painted animals on cave walls, traveling through cold and empty space, untouched and unbent, arriving only now to shimmer faintly above us, it creates a kind of awe that is hard to put into words. Perhaps that is why Andromeda has always inspired both astronomers and dreamers. It offers us the rare chance to experience scale not as a mathematical fact, but as a feeling, a sensation of being suspended, between our tiny human life and the incomprehensible enormity of the cosmos. There is also the matter of motion, and though it belongs more properly to the next steps of our journey, it already whispers its presence here. Andromeda is not static in the sky. It is moving, drawn toward us by immense gravitational threads stretching across the local group. It is our cosmic neighbor, not only in proximity, but in destiny. And that knowledge adds a strange depth to everything we've mentioned. To think that this glowing island of stars, already woven into human culture and human curiosity, is slowly, inevitably coming closer. And well, as we let these thoughts settle gently around us, like dust drifting through a sunbeam, you might start to feel that Andromeda is not simply a galaxy out there, far away and unreachable. It is a part of the story of our own galaxy, a companion across time and space, a reminder that even on the largest scales, the universe is shaped by relationships. Every fact about Andromeda, from its bright core to its sprawling halo, carries with it a sense of connection. And perhaps that is where we can pause for a breath, letting the vastness of what we have explored so far settle softly in the mind. Because as we move deeper into our journey, the question of Andromeda's size and structure begins to open the doorway to something even more intricate and mesmerizing, something that awaits us just beyond this moment, in the long spiraling arms of the next chapter. And so, as we linger for a moment on that threshold between wonder and understanding, the shape of Andromeda gradually comes into focus, not as a distant blur, but as a vast architecture of stars. You know, when people first hear the number, a diameter of more than 220,000 light years, they often nod as though it's merely another statistic. But if you pause and really let that scale settle into the mind, it feels almost impossible. A light year is already such an unimaginable stretch, the distance light travels in a single year, and yet here we are, speaking casually about a structure that spans 220,000 of them. Well, I suppose the mind does what it can. It lets the numbers float past like clouds, because to truly grasp them would be overwhelming. But in that vastness lies the quiet beauty of Andromeda's form. You see, at the heart of this galaxy is a core so bright and dense that it almost behaves like a single glowing entity. It is packed tightly with stars, old stars mostly, gathering there in a luminous sphere that shines like a lantern hung in the dark. When we think of a galactic core, we might imagine it as solid, but it is not. It is a storm of motion, a hive of gravitational interactions, stars weaving around one another in orbits shaped by the great mass at the center. And yet, even with all that motion, all that restless energy, the impression we receive from afar is one of stillness, like a candle that burns without flickering. Around that core stretch the great spiral arms, perhaps the most graceful features of Andromeda. These arms arc outward in sweeping curves, filled with dust lanes, blue clusters and shimmering fields of younger stars. They are not even, not symmetrical in the way one might imagine from a textbook drawing. They twist, they ripple, they bend slightly under the influence of past interactions. The galaxy carries the memory of many encounters, and those memories ripple through its structure. You can almost think of the spiral arms as rivers of starlight, flowing outward from the center, each one carrying with it a story shaped by gravity and time. And then, at the center of those spirals, hidden within that luminous core, lies something rather intriguing. Andromeda hosts a weak central bar, a stretch of stars that form a subtle, elongated shape running through the galactic nucleus. Bars like these are quite common in galaxies, though they are often more pronounced. In Andromeda, the bar is faint, almost shy, as though it prefers to hide behind the brightness of the bulge. But its presence tells us something about the internal dynamics of the galaxy. Bars are bridges for matter, channels that funnel gas toward the center, fueling new star formation or feeding the supermassive presence hidden deep within. It is a reminder that galaxies evolve from the inside outward, their very cores sculpting the shape of all that surrounds them. If we drift outward along one of those spiral arms, letting our imagination float freely across the starlit lanes, we eventually reach the galaxy's disk, an immense structure that looks smooth from afar but reveals a wealth of detail upon closer thought. Andromeda's disk is threaded with dust, thick and dark, stretching for tens of thousands of light years. These dust lanes are like cosmic rivers of carbon, silicon, and other heavy elements, the remnants of old stars that exploded and seeded the galaxy with new materials. They absorb light and cast shadows across the spiral arms, creating the mottled appearance we see from telescopes. And if you imagine traveling through those lanes, you might think of them as a kind of interstellar weather, flowing and shifting over millions of years. But the dust is only part of Andromeda's complexity, because beneath the spirals and beyond the disk lie overlapping rings of stars, faint but real, like ripples frozen on a pond after a stone has been thrown. These rings suggest past interactions, perhaps collisions with dwarf galaxies whose remnants are now woven into Andromeda's structure. When astronomers observe these rings, they see evidence of a galaxy that has grown through encounters, absorbing smaller systems, folding their stars into its vast body. The rings are not merely decorative, they are history, written in motion. And then there are the multiple layers of structure that stack one over the other, like sheets of cosmic glass. Andromeda contains not just a disk and a bulge and a halo, but more subtle, interwoven components. Shells of stars drifting at different speeds, stellar streams looping around its outskirts, and faint arcs that speak of long-forgotten events. The galaxy is almost like a palimpsest, a manuscript written over many times, where the older writings still shine through beneath the newer ones. And when you think of it that way, Andromeda becomes less a static object and more a living chronicle of the universe. What I find particularly moving is how Andromeda's complexity reveals a truth about the cosmos. Structure is never simple, even when it appears elegant from a distance. The spiral arms may seem smooth, but inside them lie turbulent nurseries of star birth. The halo may appear faint, but it spans as wide as several galaxies laid side by side. The core may look calm, but inside its stars roar around a deep gravitational well. And in between all of this, perhaps, lie the quiet places, regions where time slows in the human imagination, where stars drift alone through the soft darkness. And, when we compare Andromeda to our own Milky Way, something almost tender begins to emerge. Andromeda is more complex, more structured, more layered. It has grown larger, shaped by interactions that have left their fingerprints all across its form. And though complexity does not necessarily mean superiority, it does mean history. Andromeda carries with it the long memory of a galaxy that has been sculpted again and again by gravity's persistent hand. And in those layers, in those overlapping rings and faint streams, we glimpse the story of a universe that never stops changing. If you lean into that thought, let it settle gently like a whisper, you begin to realize that galaxies are not separate from one another. They are part of a grander tapestry, threads woven together across time. Andromeda's complexity is not only its own, it is shared with the smaller galaxies that once orbited it or passed near it, whose stars now form its faint outer structures. It is shared with the local group itself, whose gravitational currents tug and pull at Andromeda and the Milky Way alike. We are connected to Andromeda, not simply by proximity, but by destiny, by the subtle gravitational drift that draws our galaxies slowly together. And well, as we take in the full breadth of Andromeda's structure, from its bright core to its ghostly halo, from its dusty spirals to its overlapping rings, there's a feeling that begins to rise, a quiet one, soft as breath. It is the feeling that we are witnessing not just a galaxy, but an unfolding, an ongoing creation. And when you begin to sense that, the next question gently approaches like a tide returning to shore. Because if Andromeda is this immense, this layered, this intricately built, then what does it mean that it lies so far away, drifting across the void toward us? What does distance mean when light takes millions of years to cross from one place to another? And what does motion mean when two galaxies as vast as these are slowly falling together? And that, I suppose, is where our journey naturally leads us next, toward the great expanse that separates us from Andromeda and the slow gravitational dance drawing our galaxies across the deep dark of space. And so, as that thought settles, like a grain of stardust drifting through a quiet beam of light, we find ourselves standing before one of the most astonishing truths about Andromeda: the space between us. You know, we often think of distance as something simple, something we can hold in our minds the way we hold the distance between two cities or two mountain peaks. But when we speak of the gap between the Milky Way and Andromeda, we are speaking of a gulf so wide that even light, the fastest thing the universe has ever known, takes about 2.5 million years to cross it. And yet, perhaps the strangest part is this: despite all that emptiness, despite the silence of deep space stretching between our galaxies, we are moving toward one another, slowly, steadily, inevitably. It is as though two islands of light, separated by an ocean without waves, are drifting together on currents shaped by gravity alone. You see, the distance between us and Andromeda is often described as a number, 2.5 million light-years, but the reality is more like a story written in the language of time. The Andromeda you see tonight, even in the faint glow of 2025, is a version of the galaxy that existed when early humans were only just beginning to shape tools and dreams. And if you imagine that light traveling through the vast dark, unhindered by anything at all, arriving only now to meet our gaze, you begin to sense the scale of what lies between us. It is not merely distance. It is a gulf of ages, a reminder that the universe is always speaking to us from its past. And well, that gap is not empty in the way we imagine emptiness. Dark matter threads through it like invisible rivers. Tiny galaxies, some too faint to see, drift in that expanse like sparks floating through a night breeze. Clouds of stray hydrogen stretch across it, thin as whispers. And all of this, quiet as it seems, is part of the gravitational pull that draws the Milky Way and Andromeda together. Gravity, after all, is patient. It waits. It works slowly, almost gently, over billions of years, guiding entire galaxies along paths that seem almost predestined. Perhaps what feels most surprising is the speed at which Andromeda is approaching us, about 110 kilometers every second. Now, if someone on Earth were moving that fast, we would think of them as streaking across the sky like a meteor. But in the scale of cosmic motion, that speed is modest, almost leisurely. Still, it tells us that the gap between our galaxies is shrinking. Each second, each minute, each passing moment, Andromeda is a little closer than before, and as our galaxies move toward one another, the stars within them carry on without any awareness of this great cosmic migration. And, when you picture this approach, it is tempting to imagine something violent. Two enormous spirals of stars crashing together with explosive force. But the truth, and this is one of those beautiful counterintuitive truths of astronomy, is that when Andromeda and the Milky Way finally meet, the stars within them will almost never collide. The scale is simply too vast. Stars are so far apart that even in a galactic merger, they pass by one another like fireflies drifting through a wide-open field. They influence one another through gravity. Yes, bending paths, stirring orbits, altering the grand architecture of the galaxies. But direct collisions between stars are extraordinarily rare. Instead, what will happen is something slower, more graceful, almost like two great cosmic dancers drawing near, their arms brushing softly as they spiral together. The shapes of both galaxies will distort, stretch, warp into long tidal tails. Their centers will pass through one another, swing apart, and then be pulled back again until eventually, after perhaps a few billion years, they merge into a new, larger galaxy. Some astronomers like to call this future creation Milkdromeda, and though the name may sound whimsical, The idea itself is profoundly moving. The two great galaxies of our local group will become one, the light of their stars intertwined. What is even more astonishing is that this future is not something we can escape. It is woven into the fabric of our galaxy's motions, and while this might feel unsettling, as if the future of the Milky Way is already written, I suppose there is a sense of inevitability in the cosmos. Gravity writes its own history. Andromeda is coming toward us, not because of chance, but because the mass of both galaxies draws them together in a slow, vast embrace. But before that distant future arrives, there is something deeply compelling in the present moment. The knowledge that this great motion, this approach across millions of light years, is something we can measure, understand, and even predict. It is one of the triumphs of astronomy that we can look at the slight blueness of Andromeda's light, the subtle shift in its wavelength, and determine that it is moving toward us. Most galaxies in the universe are moving away, their light stretched into redness by the expansion of space itself. But Andromeda is one of the few that approaches. That simple fact quietly reveals our shared gravitational destiny, and when you imagine this slow convergence, it begins to stir questions that go beyond the facts. What does it mean that galaxies move toward one another in the dark, across stretches of space where nothing else exists? What does it mean that we, living on this small planet orbiting an ordinary star, are part of a story that spans billions of years? It makes you wonder if time itself is not just something we pass through, but something that flows around us, carrying us along on currents far older and deeper than human memory. When Andromeda and the Milky Way eventually merge, the night sky will transform. The great spiral of Andromeda will grow larger and brighter over millions of years until it dominates everything. Future beings, whoever or whatever they may be, will see a sky filled with arcs of light, streaks of dust, and swirling star clusters. The calm, familiar band of the Milky Way will be replaced by something grander and stranger. The collision will stir star-forming regions into brilliance. Clouds of gas will collapse into new suns. The galaxy will become a place of renewed activity. And yet, even then, despite all this grandeur, Earth itself will not be destroyed by the merger. The vastness of space between stars protects it. The sun may be nudged along a new orbit, perhaps even flung a little farther from the center of the merged galaxy, but the solar system will likely remain intact. It is humbling to think that on cosmic scales, even chaos is gentle. Still, this movement toward Andromeda is more than an astronomical curiosity. It is a reminder that nothing in the universe is stationary. Everything moves, everything changes. Galaxies drift, collide, reshape themselves. Stars are born and die. Even the space between galaxies expands and contracts in response to deeper forces, and in that motion lies the pulse of the cosmos. And well, as we let our imagination float across this immense gap between galaxies, feeling the slow gravitational pull drawing us together, there is a quiet sense of continuity. Andromeda is no longer just a distant island of stars. It is a future companion, a collaborator in a cosmic transformation that has already begun, even if the effects will only be felt billions of years from now. If you listen closely, almost like listening for a soft sound at the edge of a dream, you might sense that this great movement is not the end of the story, but the beginning of a deeper one. Because as Andromeda approaches, as we consider the vast gulf between us and the slow dance that binds us together, we must also turn our eyes back toward the past. Someone had to see this first. Someone had to wonder what that faint blur in the sky truly was. Someone had to ask the question that opened the doorway to the modern understanding of galaxies. And so, from the motion of Andromeda across the void, we drift naturally, quietly, into the history of how humans first observed it, long before we knew its name, long before we knew its nature, back when it was merely a mysterious patch of light flickering in ancient skies. Well, you see, as we follow that gentle thread of thought from the cosmic motions drawing Andromeda toward us, the mind can't help but drift backward, toward the very first moments when human beings looked up and tried to make sense of the faint blur that would someday alter our understanding of the universe. It is almost poetic, isn't it? The idea that long before we knew what a galaxy was, long before we imagined spirals of stars or distances measured in light years, someone, somewhere, noticed that there was a patch of light in the sky that did not behave like the others. It was softer, more diffuse, more mysterious. And to those early observers, it must have seemed like a cloud caught in the firmament, a strange wisp that did not move like a planet, nor twinkle like a star. It simply was there, lingering in the darkness, as though waiting to be understood. And, if we let our imagination drift back to antiquity, perhaps to a hillside under a quiet Persian night, we can almost see an early astronomer gazing upward with nothing but his eyes and his curiosity. Andromeda appears in some of the earliest astronomical documents from Persian scholars, described not as a galaxy, of course, but as a small, cloud-like object. There is a kind of sweetness in that simplicity. They saw only what the human eye could reveal, yet that was enough to spark wonder. In fact, it would take centuries before anyone understood that this faint light came from beyond the Milky Way. For a very long time, Andromeda was believed to be a nebula, a cloud of gas inside our own galaxy. And who could blame early astronomers for thinking that? Even with modest telescopes, it appeared diffuse and ghostly, nothing like the sharp pinpoints of stars around it. It was called the Andromeda Nebula, and that name carried with it a sense of closeness, as though this strange object belonged to us, another part of the Milky Way's own structure. And well, I suppose there is something touching in that misunderstanding. Humans often assume that the world they see is the entire world. It is only later, with curiosity and courage, that the boundaries of the familiar begin to expand. Over the centuries, as telescopes improved and lenses grew clearer, more detail emerged. Astronomers began to notice that the Andromeda Nebula contained a bright central region and faint structures surrounding it, almost like the beginnings of a spiral. But even then, the idea that it was a separate galaxy was almost unthinkable. The universe, as imagined in those times, was much smaller. The Milky Way was seen as the whole cosmos, and everything else was thought to reside within it. To claim otherwise was to rearrange the map of existence itself. And that is exactly what happened in the early 20th century, when Edwin Hubble stepped onto the stage of cosmic history. I always find this moment incredible, almost cinematic. Imagine Hubble standing at the eyepiece of the Hooker telescope on Mount Wilson, one of the most powerful instruments of its day. Night after night, he photographed the Andromeda Nebula, studying it carefully. Eventually, he spotted something remarkable: individual stars within the nebula, specifically a type of star known as a Cepheid variable. These stars change brightness in a predictable rhythm, and from that rhythm, their distance can be calculated. When Hubble performed those calculations, he realized that the Andromeda Nebula was far, far too distant to belong to the Milky Way. It was its own galaxy, another vast island of stars. And, in that moment, everything changed. The universe suddenly expanded. The Milky Way was no longer the entirety of existence. It became just one among countless galaxies scattered across the cosmos. You see, it is difficult for us, living in the age of 2025, to grasp how shocking that discovery was. Today we grow up knowing about galaxies and cosmic distances. But for Hubble's era, the idea shattered centuries of assumptions. It opened the door to a universe filled with other structures like our own, each one containing billions or even trillions of stars. And Andromeda, once a mysterious cloud in the sky, became the first great signpost pointing toward that larger realm. This shift in understanding did more than change astronomy. It changed philosophy. It changed the way humanity saw itself. Suddenly, we were not at the center of a small, self-contained universe. We were inhabitants of a vast cosmic ocean, floating within one galaxy among many. And well, with that revelation came a sense of both humility and wonder. The universe was bigger than we had dared imagine, and yet we were part of it, able to measure it, able to understand it. What I love most about this chapter in history is how it reveals the partnership between curiosity and patience. The ancient Persians recorded Andromeda because they were attentive to the sky. Later, astronomers questioned its nature because they refused to accept simple explanations. And Hubble, with his methodical study and his willingness to challenge long-held beliefs, gave us a universe that was suddenly infinite. Science, in this way, is like a slow unfolding of truth, each generation lifting another layer of mystery. But if we look deeper, there is something even more resonant in this story. Andromeda became proof that the universe is far larger than the Milky Way, yes, but it also became evidence that our understanding of reality evolves. We learn, we grow, we refine our vision of the cosmos, and perhaps in that progression there is a lesson about ourselves. Just as Andromeda revealed its true nature through patient observation, so too do we reveal our own potential by questioning our limits. And the recognition that Andromeda is a galaxy on its own also planted the seeds for further discoveries about galactic motion, dark matter, cosmic expansion, and even the fate of the universe itself. It is extraordinary to think that one small smudge of light in the night sky could unlock so many doors. It reminds us that sometimes great truths begin as faint whispers, barely noticeable unless we are willing to listen. When astronomers realized the universe contained countless galaxies like Andromeda, the sky itself transformed. What had once been a dome scattered with stars became a vast, three-dimensional tapestry stretching across billions of light years. The night sky became deeper, more layered, more hauntingly beautiful. And Andromeda, shining quietly among the constellations, became a symbol of that greater truth. It is one thing to observe a star. It is another to realize that the light you are seeing comes from an entire world of stars. That transformation of scale rewires the imagination. And so, from the first ancient scholars to Hubble's decisive observations, Andromeda has led humanity toward a more expansive understanding of the cosmos. Each discovery peeled back another layer, like stepping through a series of doorways, each one opening into a larger room. And we, following that path, now stand with a clearer view of the universe and our place within it. But even as the history of Andromeda's observation inspires us, it also invites us onward. Because once we understand that Andromeda is a galaxy in its own right, sprawling with stars and structure, the next question naturally arises. If a galaxy contains billions of stars, could some of those stars harbor worlds? Could planets, perhaps countless planets, circle those distant suns? And well, as we drift closer to that line of thought, like moving from one quiet chamber of the mind into another, we begin to sense that our journey is not finished. We have explored the origins of our knowledge, the way humans first looked at Andromeda. But now, gently illuminated by that history, we turn toward a new mystery waiting in the depths of that galaxy. The possibility of planets, of worlds, and perhaps even life, orbiting far beyond our reach, hidden somewhere among the trillions of stars. Well, you see, once we step through that doorway opened by history, once the realization settles that Andromeda is not merely a glowing patch in our sky, but an entire galaxy of its own, another thought begins to drift into focus. It comes softly, almost shyly, the way a question rises at the back of the mind just before sleep. If Andromeda contains so many stars, could some of them have worlds? Could planets, perhaps billions of them, be circling quietly around their suns, hidden beneath that distant shimmer of light? It is a thought that feels almost too large to hold, and yet strangely intimate, as if we are asking whether somewhere, far across the darkness, there might be landscapes, oceans, winds, and perhaps even stories unfolding on worlds that have never known Earth. You know, when we talk about planets in our own Milky Way, it has already become clear that planets are not rare jewels, but common companions to stars. Almost every star, it seems, hosts at least one, and many host entire systems. So when we look toward Andromeda, a galaxy larger than our own, richer in stars, a sprawling city of light, the probabilistic truth becomes almost overwhelming. There could be billions of planets there, not just a handful, not hundreds, not thousands, billions. And among those billions, some would be rocky, some gaseous, some frozen, some scorched, some washed with oceans, some buried under ice. The full range of planetary diversity that we see here would exist there too, multiplied on a scale that pushes the imagination to its limits. And, it's almost funny, in a gentle way, how easy it is to forget that each tiny point of starlight we see in Andromeda, blurred together into that faint cosmic cloud, is itself a sun. Not metaphorically, not symbolically, but literally a sun, burning with its own light and heat, generating its own gravity, possibly nurturing its own retinue of planets. When you think about it that way, the galaxy becomes less a distant glow and more a grand mosaic of potential worlds. Some of those worlds may resemble Earth in subtle ways. Rocky surfaces, warm atmospheres, the possibility of liquid water. Others might orbit stars dimmer and redder than our sun, stars we call red dwarfs, small but long-lived, their light steady and cool. Around such stars, planets could circle in tight orbits, worlds lit by a soft crimson glow. Red dwarf systems, you see, are both intriguing and mysterious. They make up the majority of stars in any galaxy, including Andromeda. And because they burn their fuel slowly, they live for trillions of years, far longer than stars like our sun. This longevity offers something precious: time. Time for atmospheres to form, for oceans to settle, for chemistry to dance its long, patient dance. Perhaps in Andromeda's countless red dwarf systems, there are planets where dawn stretches red across alien mountains, where water pools in deep basins, where life, if it exists, has had ages to adapt to the gentle pulse of a faint star. And then there are other kinds of worlds, worlds stranger and more haunting. Some planets may orbit far from their stars, receiving almost no light at all. These would be dark worlds, places where warmth might bubble up from the core rather than shining from above. If life exists there, it might gather near volcanic vents or beneath thick ice, glowing softly in bioluminescent webs. It is a strange thought, perhaps, but not impossible. After all, on Earth, in the darkest corners of the ocean where sunlight never reaches, life thrives around geothermal vents in shimmering ecosystems powered by heat from below. And well, there may even be ocean worlds in Andromeda, planets covered entirely in water, their surfaces roiled by storms, their depths hiding continents of possibility. Imagine a world with no land at all, where life, if it arises, might bloom in warm currents, drifting and evolving in ways we can only guess. The physics of such a world would be different, its climates shaped by the dance of deep tides and internal heat. And yet, in the quiet dark of that galaxy, such worlds could be common, countless, moving through their long orbits in silence. If we lean into that thought, let it take its time, we begin to see Andromeda not just as a galaxy, but as a vast cradle of potential. For every bright star there are countless smaller ones, and for every star there may be planets, some barren, others vibrant. Perhaps there are worlds with skies tinted green by unfamiliar atmospheres, worlds with rings casting shadows across their surfaces, worlds with twin suns rising together, or planets locked in eternal twilight, their rotations synchronized so that one side faces its star forever, while the other lies in unending night. And, in all of this speculation lies something deeply human. We cannot help but imagine. We cannot help but wonder whether somewhere in Andromeda, perhaps on a planet orbiting a quiet star in a distant arm, life might be contemplating its own sky. Maybe there are beings who watch the faint glow of our Milky Way and ask questions similar to ours. What is that light? Is it one object or many? Are there worlds hidden within it? Could someone be looking back? It is an idea that is both humbling and strangely comforting, as though the universe fosters curiosity wherever conditions allow it. Of course, we must also acknowledge the uncertainty. At this moment in 2025, we cannot directly observe planets in Andromeda. We cannot see their silhouettes or measure their atmospheres the way we can for planets in our own galaxy. The distance is too great. The light, too faint. But probability can be a powerful guide, and every new discovery in exoplanet science strengthens that feeling that planets are an ordinary outcome of star formation. If the Milky Way hosts billions of worlds, Andromeda likely does too, perhaps even more, given its larger mass and richer stellar population. There is something poetic in this absence of direct evidence. The planets of Andromeda, if they exist, are whispers behind a curtain still hidden from us. Their oceans, continents, atmospheres, if they are there, remain secrets locked behind the glow of the galaxy's combined starlight. Yet the possibility alone expands the imagination. It reminds us that the universe is full of unseen wonders, waiting patiently for the moment when our instruments grow sharp enough, our methods clever enough, our reach long enough to unveil them. And there is another compelling layer to this thought. If Andromeda contains billions of worlds, then among them must be planets that orbit stars much older than the Sun, planets where the chemistry of life has had far more time to unfold. What might arise in such places after billions upon billions of years? Would life remain simple, content to fill oceans and soils with quiet persistence, or would it grow complex, evolving forms and abilities shaped by alien climates? Would intelligence arise not once but many times, each civilization shaped by the rhythms of its own world, staring up at its own night sky? It is tempting to imagine such civilizations pondering the future collision between Andromeda and the Milky Way, just as we do. Perhaps they too measure the slow drift of galaxies. Perhaps they too look across the void and see our home as a faint glow. And though such speculation remains firmly in the realm of imagination, it is the kind of imagination that feels anchored to possibility rather than fantasy. The universe, after all, is vast enough, old enough, and creative enough to allow for things stranger than any story we might invent. And well, even if we never meet any such beings, even if communication across millions of light years remains forever beyond our reach, the simple notion that Andromeda could cradle life transforms it from a distant object into a kind of cosmic companion, a sibling galaxy, rich with its own evolutions, its own weather, its own chances. It becomes part of a wider cosmic ecosystem, where galaxies are not merely structures of gas and stars, but vast arenas where complexity can flourish. As we let these thoughts settle, like stars drifting into alignment in the quiet of the mind, we find ourselves standing on the edge of another revelation. If Andromeda holds planets and perhaps life, then what lies at its center? What immense engines drive its structure, shape its stars, influence the orbits of entire systems? We have wandered through the possibilities of distant worlds, gently imagining the oceans and atmospheres that might exist across its arms. But now, slowly, almost as if guided by gravity itself, our attention turns inward, toward the heart of Andromeda, where something far more powerful waits in the luminous depths, a supermassive presence hidden inside the galaxy's blazing core, shaping everything around it. Well, you see, as we drift inward from those imagined worlds scattered like tiny lanterns around Andromeda's stars, our path naturally bends toward something deeper, something far more powerful waiting at the heart of the galaxy. It is almost like descending from the gentle surface of a great ocean into the dark, pressurized depths where titanic forces dwell. The planets and their quiet orbits form the outer stories of Andromeda, but at the very center lies a force that shapes every motion, every swirl of gas, every luminous breath of the inner spiral. And perhaps, if we listen closely enough, we can feel that pull even across the vast gulf that separates us. This presence, this supermassive being, is a black hole. Not a poetic metaphor, but a literal region where gravity becomes so intense that not even light can escape. Andromeda's black hole is enormous, weighing hundreds of millions of times more than our sun, a mass so heavy that the human mind almost crumples trying to imagine it. And yet, strangely, black holes are not the consuming monsters we once feared. They are part of the natural architecture of galaxies, anchors around which everything else moves. In many ways, they are the hearts of galaxies, invisible but essential. shaping the rhythms of the cosmos. You know, when we think of a black hole, we often imagine a kind of cosmic drain pulling everything inward with unstoppable hunger. But that image, while dramatic, misses the stillness at the center of these objects. A black hole does not chase or devour. It simply bends space-time so sharply that anything passing too close, light, gas, or the occasional wandering star, is caught in its embrace. The black hole at the center of Andromeda is quiet now, or at least relatively so. It glows faintly, fed only occasionally by drifting gas or unlucky stellar debris. But in the distant past it may have burned bright, shining as a quasar, a beacon of energy so powerful it could have outshone the entire galaxy. And, if we let the imagination drift inward toward that central region, a very different landscape comes into view. The stars nearest to the black hole do not move in gentle circular paths. They hurtle around the core at tremendous speeds, whipped around by the immense gravitational force of that hidden mass. Their orbits are tight, elongated, chaotic. The closer they are drawn, the faster they move, as though dancing on the edge of a cosmic whirlpool. And the black hole itself, silent and dark, lies at the center like an absence given shape by the motion of everything surrounding it. It is fascinating, perhaps even unsettling, to realize that black holes do not simply sit at the center of galaxies. Galaxies are built around them. Andromeda's structure, from its bright bulge to its dim outer halo, is linked to the gravitational influence of this central mass. Without such a concentration of matter in the middle, the galaxy would not hold itself together in the way it does. Stars would drift more freely, the rotation would be looser, the spiral arms less defined. The black hole provides a kind of gravitational scaffolding, an anchor point around which the galaxy's identity forms. And yet, despite its colossal size, despite the immense weight it carries, the black hole is incredibly small in spatial terms. You could place the entire solar system around it with room to spare. Its radius is tiny compared to the galaxy that surrounds it. There is something profoundly humbling about that contrast. A mass hundreds of millions of times greater than the Sun, folded into a region far smaller than the space occupied by our planetary neighborhood. It forces us to reckon with the strangeness of the cosmos. Mass and size do not always align. The universe hides its greatest forces in its smallest rooms. If you picture Andromeda's core as a glowing sphere, the black hole sits at its center like a dark seed. Around it, the stars grow older and denser. Some of these stars are remnants of earlier generations, ancient suns that burned through their fuel long before our own sun ignited. Their light is softer, redder, like embers simmering in the twilight of cosmic time. These old stars move in complicated paths, constantly accelerated and redirected by the gravity of the central black hole. To watch them is to watch a kind of cosmic ballet choreographed by forces beyond comprehension. And, well, there is another layer to this. The black hole shapes not only the motions of nearby stars but also the flow of gas and dust across the inner galaxy. When gas clouds drift too close, they are stretched and heated, swirling into an accretion disk that glows with immense energy. Even when the black hole is not actively feeding, its presence influences the distribution of material, affecting where stars can form and how they evolve. In this way, the black hole becomes not just a destructive force but also a creative one, sculpting the environments in which new stars, and perhaps new planets, may someday emerge. Sometimes I wonder what it would be like to float near the edge of that accretion disk, to hover safely at a distance where gravity's pull is strong but not fatal, watching the luminous swirl of heated gas as it spirals inward. It would not be silent. The disk would roar with radiation, a furnace hotter than anything we can imagine. Yet beyond that inner ring, the stars would drift peacefully, oblivious to the fiery storm so close by. The contrast between violence and serenity is one of the universe's great paradoxes, and nowhere is it more apparent than near a supermassive black hole. Andromeda's black hole is similar in many ways to the one at the center of our Milky Way, known as Sagittarius A. Both are supermassive, both act as gravitational anchors, both influence the behavior of their surrounding stars. But Andromeda's central black hole is much larger, hundreds of millions of solar masses compared to the 4 million solar masses of Sagittarius A. It is a difference that reflects the larger scale of the galaxy itself. Andromeda has grown more massive over cosmic time, likely by consuming smaller galaxies. With each collision, each merger, it may have fed its central black hole, allowing it to grow into the colossal giant we see today. This process, galactic cannibalism if you want to use the dramatic term, is part of what shapes galaxies across the universe. As Andromeda absorbs smaller galaxies, their stars become part of its halo, their gas becomes fuel for new star formation, and their central black holes merge with Andromeda's own. In this way, black holes grow over billions of years, quietly becoming heavier with each encounter. It is a strange kind of evolution, one that takes place on timescales far beyond anything human minds can intuit. If we think of Andromeda as a great cathedral of stars, then the black hole is its foundation stone, buried deep beneath the brightest lights. It is invisible, yet everything depends on it. And perhaps that tells us something subtle about the universe. Some of the most important forces, the ones that shape everything we see, remain hidden. We infer their existence not by observing them directly, but by noticing how everything moves around them. Truth in the cosmos is often revealed by shadows, and the presence of this supermassive black hole also offers clues about the future. When Andromeda and the Milky Way eventually merge, their central black holes are expected to spiral toward one another, losing energy through gravitational waves, until they finally fuse into a single, even larger black hole at the heart of the new galaxy. This event, though unimaginably far away, would release a burst of gravitational ripples across space. Perhaps some future species, living on a distant world long after Earth is gone, will detect those waves and understand that they are listening to the echo of a great cosmic union. But even before that distant future unfolds, the black hole continues to influence Andromeda's present. Its gravitational field dictates the inner galaxy's dynamics. Its occasional bursts of energy may heat surrounding gas, slowing or shaping star formation. Its sheer presence serves as a kind of gravitational memory, a record of all the matter that once passed too close. Black holes, after all, are not empty. They are filled with the history of everything they have consumed. And well, perhaps what moves me most is the quiet mystery that remains. Even in 2025, with all our telescopes and instruments, black holes challenge our understanding of physics. They sit at the dividing line between what we know and what we do not. They warp space-time, collapse matter, and test the limits of our theories. The black hole in Andromeda is not just a cosmic engine, it is a question, a riddle set at the center of a galaxy. As we drift away from this luminous heart, letting the idea settle like a fading vibration, we begin to notice something else surrounding Andromeda. The galaxy is not alone. It is accompanied by a collection of smaller companions, satellite galaxies orbiting its vast halo, drawn into its gravity, shaped by its pull. And these companions, too, have stories of distortion, of tidal stretching, of slow and patient destruction as Andromeda absorbs them over time. So perhaps now, gently guided by the gravitational wake of the central black hole, we allow our attention to move outward once again, toward those small galaxies that circle Andromeda like distant lanterns. Because to understand a great spiral galaxy fully, we must also look at the company it keeps, the satellites that drift at its edge, some bright and some fading, yet all part of its evolving history. Well, you see, as we drift outward from the luminous heart of Andromeda, leaving behind the immense silence of its supermassive black hole, the galaxy begins to reveal another layer of its story, one that circles quietly around it, almost like a constellation of companions keeping watch at the edge of a great kingdom. These companions are its satellite galaxies, more than 30 of them, each one a small world of stars in its own right, each one bound to Andromeda by the long, invisible threads of gravity. And, there is something strangely touching in that image, a giant spiral galaxy surrounded by a retinue of smaller ones, drifting together through the deep night of the local group. If we imagine Andromeda as a great lantern burning in the cosmic dark, then its satellites are like tiny candles flickering around its rim. They vary in brightness, in size, in shape. Some are compact and surprisingly bright, while others are faint wisps, so diffuse that they almost disappear into the velvet of space, and the closer we look, well, the more it becomes clear that each one carries its own quiet history, shaped not only by its internal dynamics, but by the overwhelming influence of Andromeda's immense gravitational field. Among these satellites, two stand out like old friends often seen in Andromeda's portraits, M32 and M110. M32 especially is a curious little galaxy. It is compact, bright, almost too bright for its size, as though its stars have been squeezed together by some ancient encounter. Many astronomers believe that M32 was once a larger galaxy, perhaps with spiral arms of its own, before a close interaction with Andromeda stripped away much of its outer structure. What remains is a dense elliptical core, a kind of galactic fossil, the remnant of something that once was much grander. M110, another prominent satellite, tells a similar but softer tale. It is more diffuse than M32, with a gentler glow, like the lingering trace of a galaxy slowly losing itself to time. Its stars are older, its features blurred by the gravitational tides that have pulled at it for millions of years. Both M32 and M110 are reminders that the space around a massive galaxy is not peaceful. It is a place of slow-motion interactions, of stars stolen or scattered, of structures stretched thin by the pull of gravity. And, it is not just these two. There are dozens of dwarf galaxies that orbit Andromeda. Tiny, fragile structures that would barely register to the human eye if placed in the night sky. Some are so faint that they were only discovered in recent decades, hidden like faint whispers among the broader glow of Andromeda's halo. They drift at various distances, some close enough to be visibly distorted, others so far that they seem like solitary wanderers, even though they remain gravitationally bound. Orbiting a giant like Andromeda is not an easy life. The gravity of the host galaxy stretches these satellites, elongates them, and sometimes tears them apart entirely. Many of the streams of stars we see in Andromeda's halo, the long, faint rivers of starlight that wrap around it like delicate threads, are actually the remnants of galaxies that Andromeda has begun to consume. What once were independent systems with their own orbits, their own interstellar clouds, their own small clusters of stars, have been pulled into Andromeda's vast embrace, added to its mass, woven into its structure. It is, in a sense, cosmic cannibalism. But not the violent kind that we might imagine. Instead, it is a slow, tidal process, stretching across hundreds of millions of years. A dwarf galaxy approaches Andromeda, perhaps drawn inward after billions of years of drifting. At first, nothing seems unusual. The stars continue in their quiet orbits. The galaxy maintains its shape, but as it draws closer, Andromeda's gravity begins to influence it more strongly. The outer stars are the first to feel the strain, pulled into faint arcs that trail behind the dwarf like stardust. Over time, these arcs widen, becoming long tails of debris that wrap around Andromeda. Eventually, the dwarf galaxy loses so much mass that it can no longer hold itself together. It dissolves into the larger whole, becoming part of Andromeda's halo or spiral structure. And, well, this process is not a rare event. Andromeda has consumed many galaxies over its lifetime, swallowing them piece by piece. Some theories even suggest that M32 itself may be the dense core of a galaxy that was once spiral, its outer layers torn away by Andromeda's tides. In that sense, M32 is not just a companion, it is a survivor of a cosmic encounter. These interactions serve as reminders that galaxies are not isolated islands. They are participants in a constant exchange of matter and motion, shaped by a complex web of gravitational relationships. The satellites orbiting Andromeda today may not exist in the same form a billion years from now. Some will fall inward, spiraling slowly toward their dissolution. Others might remain, drifting around Andromeda in long, looping orbits that span millions of years. A few may even escape, flung outward by gravitational encounters into the wider space of the local group. There's something deeply humbling in this. We tend to think of galaxies as permanent, unchanging structures. But when you look closely, really closely, you see that they are alive with motion, with transformation. The satellites of Andromeda are both witnesses and participants in its evolution. Their distortions tell us about past collisions. Their positions hint at future changes. Their gradual dissolution feeds Andromeda with new material, allowing it to grow and reshape itself. Without these companions, Andromeda would not be what it is today. And, if we imagine ourselves drifting among these faint dwarfs, perhaps positioned at the edge of M32 or floating through the sparse stars of a dimmer satellite, the night sky would look incredibly strange. Andromeda would dominate the sky, not as a faint smudge, the way it appears from Earth, but as a sprawling, luminous arc that cuts across the darkness. Its spiral arms, glowing softly with millions of stars, would stretch overhead like a celestial bridge. It would be both beautiful and overwhelming, an ever-present reminder of the immense force that governs every motion around it. These satellite galaxies, though small, also help astronomers trace the shape of Andromeda's gravitational field. Their orbits reveal the unseen distribution of dark matter that surrounds and permeates the galaxy. By studying the way these dwarfs move, how fast, in what direction, how far, they become test particles in a much larger cosmic experiment, showing us the hidden mass that cannot be detected through light alone. In this way, the satellites act almost like messengers, carrying information about the deeper structure of Andromeda. But beyond the science, beyond the measurements and calculations, there is something almost poetic in the idea of these tiny galaxies drifting in Andromeda's gravitational embrace. They are like memories, remnants of collisions long past and harbingers of future encounters. Some, like M110, glow softly with the light of old stars. Others are little more than faint smudges, barely holding themselves together, and yet all of them share the same fate, moving around their massive host in slow, sweeping arcs that span millions of years. And as we let that image fill our minds, as the satellites drift like fireflies around a giant lantern, we realize that the edges of Andromeda are not quiet places. They are places of motion, of tension, of transformation. They reveal the galaxy's appetite, its history, its gravitational authority. And while this flow of stars, this constant exchange between a galaxy and its satellites, leads us naturally toward another phenomenon surrounding Andromeda, one written across its halo, like faint scars left by ancient events. The stellar rings, the streams, the arcs of starry debris that stretch across its outskirts. These are the traces of galaxies long consumed, the fingerprints of a past filled with mergers and encounters. So perhaps now, carried gently by the orbits of these satellites, we drift outward once again, into the faint, ghost-like structures that surround Andromeda, the long rivers of starlight that reveal the galaxy's deep and restless history. Well, as we continue drifting outward from those fragile satellite galaxies, M32, M110, and the many dimmer ones stretched thin by Andromeda's gravity, you begin to notice something else shimmering in the galactic outskirts. Something that is not a single object, not a companion galaxy or a solitary cluster, but long, delicate structures etched across the halo like strokes of pale ink on black paper. These are the stellar streams, the rings, the great looping arcs of stars that thread around Andromeda's vast body. And, there is something almost ghost-like about them. They appear faint, fragile, yet they carry within them the memories of entire galaxies that once drifted too close and were slowly, patiently pulled apart. You see, these streams are not accidents. They are not decorative flourishes drawn by the universe for our aesthetic pleasure. They are evidence, deep, ancient evidence, of the encounters Andromeda has lived through. Each arc of stars, each faint ribbon spiraling through the halo, is a fossil of a collision, an echo of a smaller galaxy that ventured too near and began to unravel under Andromeda's gravitational pull. To follow one of these streams in the imagination is to trace the path of a once coherent world slowly dissolving, its stars peeled away like grains of sand carried by an immense tide. Perhaps the most striking illustration of this is the giant stellar ring surrounding Andromeda, sometimes called the star-forming ring or simply the Great Outer Ring. It is enormous, spanning tens of thousands of light-years, a wide and elegant loop that seems almost too ordered to be the result of cosmic destruction. But that is the thing about galaxies. From chaos, they often create beauty. The ring itself is believed to have been sculpted by a past interaction, possibly with M32 or another now-devoured dwarf galaxy, that sent waves rippling through Andromeda's disk. Those ripples triggered star formation, leaving behind the structure we now see as a wide, luminous arc. And if you look closely at the faintest parts of Andromeda's halo, you can find streams that are even more elusive. Some are so diffuse that astronomers only detected them in the last decade or two. They wind around the galaxy like threads unraveling from an old tapestry. Their stars are usually older, quieter, having been torn from their original homes long ago. The shapes of these streams, long, arcing, sometimes doubling back on themselves, reveal the orbits of the galaxies that Andromeda consumed. They are like cosmic handwriting, inscribing on the halo the history of each merger. In a strange way, these stellar streams feel almost personal. They remind us that galaxies grow by absorbing others. That identity in the cosmos is not fixed, but built from the remnants of what came before. Andromeda is not a single entity formed in isolation. It is a composite, a mosaic of stars from many origins. Some of those stars began their journeys in small dwarf galaxies wandering the local group. Some may have been part of ancient structures that no longer exist in any recognizable form. Now they are woven together into this immense spiral galaxy we see from Earth. And then there is the giant stellar stream, one of the most prominent and dramatic of these structures. It stretches like a glowing river of stars, looping behind Andromeda in a majestic arc. Astronomers believe it is the remnant of a once sizable dwarf galaxy that ventured too close and was torn apart. What is left is this stream, a long, smooth flow of stars still following the orbit of their former home. And when you look at it, really look at it, you see not just a structure but a story in motion. A story of gravity's patient work, of time stretching across billions of years, of a galaxy being unwritten and rewritten simultaneously. And when we talk about these rings and streams, we often describe them as tidal features. But that phrase doesn't quite capture their emotional weight. The word tidal evokes something earthly, something rhythmic and gentle. But the reality is both more violent and more elegant. Imagine a small galaxy approaching Andromeda, feeling the pull on one side stronger than on the other. Stars begin to drift outward, pulled into elongated shapes. Over hundreds of millions of years, the dwarf galaxy stretches, thins, dissolves. Its stars become part of a long, shimmering arc. Eventually, the galaxy ceases to exist as anything distinct. Its identity is absorbed. Its stars join the chorus of Andromeda's halo. And yet, this is the beautiful part, the memory of that galaxy is not lost. It lingers in the stream itself, which continues orbiting Andromeda like a ghost tracing the route of a life long ended. What fascinates astronomers is that these streams allow us to read Andromeda's past the way a geologist reads the layers of a canyon wall. The positions, velocities, and densities of stars in these streams tell us when the mergers happened, how massive the original galaxies were, how Andromeda's shape responded to the collisions. It is as though the outer halo is a library of ancient events, with each stellar stream offering a chapter. And, these structures also reveal something profound about Andromeda's appetite. The galaxy has not merely absorbed one or two dwarfs, it has consumed many over billions of years. Some left clear, dramatic streams, others left only faint traces. Andromeda's outer halo, once thought to be a simple spherical glow, is now understood to be a complex layering of these remnants, a quilt of past galaxies stitched together by gravity. This layering reminds us that no galaxy remains unchanged. Even those that look calm and stately from afar carry deep histories of violence, transformation, and renewal. It is a strange and beautiful paradox that the serene elegance of Andromeda's spiral form is partly the result of messy interactions and slow, cosmic devourings. Sometimes I wonder what it would feel like to stand on a planet in one of these stellar streams, if such a planet survived the tidal stretching. The night sky would be shaped by the motion of the stream itself, the stars drawn into a long arc overhead, perhaps even forming a faint ribbon of light cutting across the darkness. And beyond that ribbon, Andromeda would dominate the horizon, its bright core rising like a luminous mountain of stars. As we drift through these thought experiments, carried along by the long arcs of starlight, a deeper understanding begins to form. These streams are not anomalies. They are essential parts of Andromeda's identity. They tell us that the galaxy we see today is the result of countless interactions. They show us that galaxies are not static. They evolve through encounters, through assimilation, through the continual exchange of stars and gas. And well, as we follow these streams outward, tracing their paths through the halo, we begin to notice something else. Regions where stars are being born again. Because while the streams tell us about Andromeda's past, its collisions, its devourings, the presence of new star-forming regions tells us something about its present. There are clouds of gas, immense and cold, drifting through the galaxy's arms. There are pockets of ultraviolet radiation shining from the surfaces of young, hot stars. There are nurseries where new suns ignite. And so, carried gently by the drifting remains of ancient galaxies, we now find ourselves turning toward that next layer of the story. The ongoing birth of stars within Andromeda, the quiet renewal that continues even as the galaxy absorbs the remnants of its past. Well, you see, as we drift from those faint stellar streams, those ghostly trails of ancient galaxies stretched thin across Andromeda's outer halo, something begins to change in the scenery of the mind. The debris of past collisions, the quiet remains of things long dissolved, slowly give way to regions where the galaxy is doing something profoundly different. Instead of unweaving the past, it is weaving the future. Instead of stretching stars into long rivers of memory, it is gathering gas, cooling it, compressing it, and kindling new light in the darkness. Andromeda is not only a place of dissolution, it is also a place of birth. It holds nurseries in its spiral arms, vast stellar cradles where new suns ignite and galaxies renew themselves. When you imagine these regions, try not to picture them as bright, colorful clouds the way astronomical images often show. Those colors are enhancements, artistic translations of wavelengths our eyes cannot see. In reality, if we were drifting inside one of these star-forming regions, it would look more like a deep, silent fog. Cold, dark molecular gas, mostly hydrogen, fills these clouds. They are so dense and thick that visible light cannot escape. And yet inside, something extraordinary is happening. Gravity begins to tug at the gas, gathering it into tighter knots. These knots compress, heat, and collapse. And eventually, deep inside them, nuclear fusion ignites. A star is born. Andromeda, like the Milky Way, has many such regions scattered across its spiral arms. But the pace of creation is not the same as it once was. Many billions of years ago, Andromeda would have been overflowing with star birth, its arms glowing with brilliant clusters of newborn suns. Today, the tempo is slower, gentler. The galaxy is older, its gas less abundant, its vast reservoirs partially consumed by previous generations of stars. This is the natural life cycle of a spiral galaxy. Star formation rises and falls like breath, intense in youth, steady in maturity, quieter in later cosmic ages. And yet, even with this slower rhythm, Andromeda remains home to countless star-forming regions. Some are small pockets, only a few light years across. Others are monstrous structures spanning hundreds of light years, immense clouds where thousands of stars may emerge over millions of years. And the most beautiful part of this is the way the young stars announce themselves. Hot, newborn stars, massive ones, burning intensely and briefly, emit ultraviolet light that sweeps through their surrounding clouds, ionizing the gas and causing it to glow. These glowing regions, called emission nebulae, are the luminous signatures of stellar birth. If we could hover above one of these nebulae in Andromeda, impossible for now but gentle enough to imagine, we might see a region filled with dust lanes weaving through glowing arcs. Young stars would shine in small clusters, their light scattering against the dust. Some might still be shrouded in the remnants of their birth clouds, visible only as faint red points. Others, slightly older, might have already carved out cavities in the gas, creating bubbles and hollows where their powerful radiation has pushed material outward. And well, what makes these regions even more intriguing is how they interact with the galaxy's motion. Andromeda's spiral arms are not solid structures. They are density waves, regions where stars and gas bunch up as they orbit the galactic center. As gas clouds drift into the denser parts of these arms, they are compressed, triggering new bursts of star formation. Then, as they move out of the spiral arms, the young clusters disperse, carrying their stars across the galaxy. It is a cycle of compression and release, creation and expansion, that traces the very shape of Andromeda's spirals. But while young stars blaze hot and bright, they do not last long. The most massive ones die in violent supernova explosions after only a few million years, a blink on cosmic timescales. These explosions scatter heavy elements into space, enriching the galaxy with the raw materials needed for planets, atmospheres, and potentially life. Some of the gas expelled by supernovae will eventually cool and settle back into new clouds, beginning the cycle again. And in that recycling lies one of the great truths of the cosmos. Every star born in Andromeda owes its existence to the death of stars that came before. As we drift deeper into these regions in the mind's eye, we might encounter something that looks vague at first, a vast, cold cloud of hydrogen and helium stretching across hundreds of light years. These are the giant molecular clouds. They move slowly, almost lazily, orbiting the galaxy. Inside them, the temperature can be only a few degrees above absolute zero, yet they are the nurseries of stars. The contrast between such extreme cold and the violent heat of newborn stars is almost poetic. Within the quietest, darkest places of the universe, the seeds of brilliance are planted. Andromeda's molecular clouds are immense, rivaling or surpassing those in our own galaxy. Some may be more massive than 1,000,000 suns. And when such a cloud collapses, it does not form a single star but hundreds, thousands, or even tens of thousands. These clusters begin their lives tightly bound, but over time, gravitational interactions nudge their members apart. Many of the stars you see scattered across Andromeda today were born together long ago, but have long since drifted away from their siblings. And, while these young stars shine brightly, there's another group in Andromeda that tells the quieter side of the story: the old stars. They make up the majority of the galaxy's population. Their light is softer, redder, their lives stable and long. They drift through the galaxy's disk and halo with patient motion, carrying with them the memory of billions of years. In some sense, the older stars offer a kind of balance to the chaos of star formation. They are the calm, steady glow that persists even as new generations rise and fade. Star formation in Andromeda, despite being slower than in the past, still holds surprises. Occasionally, Andromeda's gravitational interactions with its satellite galaxies can trigger bursts of activity. When a small galaxy passes near or through the disk, it can jostle the gas, compress clouds, and spark new waves of stellar birth. Some of the rings and arcs we now see in Andromeda's structure may have helped trigger earlier waves of star formation, leaving behind clusters that are now aging gracefully in the arms of the galaxy. If we think of Andromeda as a great city of stars, then the star-forming regions are like construction sites, places where new structures rise, reshaping the skyline. The bright young stars are like fireworks against the dark, marking moments of intense energy, and the old stars, drifting slowly, are like the long-established buildings that define the city's character. Every part of the galaxy contributes to the whole. Sometimes I imagine floating above a particularly active region in Andromeda. Below us, vast tendrils of gas curl like smoke. A bright cluster glows at the center, fresh from a burst of starbirth. Radiation washes through the cloud, carving channels and hollowing out great cavities. And just beyond the cluster, newborn stars, still wrapped in their dusty cocoons, pulse softly in the infrared, waiting to emerge. It is a place that feels both violent and tender, a landscape defined by the push and pull between gravity and radiation, collapse and expansion. And well, as we consider the great age of Andromeda, it becomes clear that star formation is not merely a scientific process. It is a story of renewal. Every young star is a promise that the galaxy continues to evolve. Every dying star enriches the interstellar medium, contributing to the next cycle. Every molecular cloud holds within it the potential for entire star systems, and perhaps, on some distant planet, a spark of life. Yet something else lingers at the edges of these thoughts. Because while star formation tells us about the present life of Andromeda, the colors and light produced by these young and old stars shape the galaxy's appearance. The mixture of blue from the newly born stars and red from the aging populations creates the palette of Andromeda, subtle, varied, and deeply informative. And so, gently carried by these drifting clouds of gas, by the ultraviolet shimmer of newborn stars and the steady glow of the old, we find ourselves nearing another doorway. The story continues not just in the birth of stars, but in the light they cast, the colors that paint Andromeda's spiral arms, the shadows formed by dust, the radiance that sets the galaxy aglow. From the process of creation, our attention now drifts toward this next idea, the interplay of light, color, and shadow that reveals the character of Andromeda's luminous form. Well, you see, as we drift onward from those quiet nurseries where new stars flare into being, something begins to change in the way we perceive Andromeda, not just as a collection of structures and histories, but as a vast canvas of light. Because in the end, everything we know about this galaxy, everything we imagine, everything we decipher from millions of light years away, it all comes to us as light. Light filtered through dust, light colored by age, light sculpted by motion, light stretched by time. And when you begin to think of Andromeda in that way, as a living tapestry woven from countless shades of starlight, a different kind of wonder rises, a quieter one, softer, perhaps more intimate. And, the first thing the eye notices, if it were close enough to truly see Andromeda in all of its detail, is the blue, that bright, youthful blue. It glows along the spiral arms, clinging to the regions where young stars are still warm from their birth. Blue stars are the youngest and most massive, the ones that burn fiercely and briefly, pouring ultraviolet light into the surrounding gas. They shine with the brilliant intensity of youth, like cosmic sparks thrown into the darkness. Where the star-forming regions cluster, where gas compresses into new suns, the blue light gathers into luminous knots. These blue patches, scattered like glowing islands, tell a very simple yet profound truth. Here, in these places, the galaxy is still alive. It is still creating. It is still renewing itself, even after billions of years. But you see, blue does not tell the whole story, because woven into the great structure of Andromeda, between those sparks of youth, lies the soft, endless red of old stars. These are the elders of the galaxy, the long-lived suns that have burned steadily for billions of years. They shine with a warm, gentle glow, less fierce than the blue, less brilliant, but far more enduring. Their light fills the bulge at the galaxy's center, a region glowing like an ancient hearth. It also drifts throughout the disk, forming the underlying fabric upon which the entire galaxy rests. Red stars are like embers carrying the memory of the galaxy's past. Every one of them is a story in slow motion, a quiet presence drifting along the spiral arms. And while the interplay between blue and red, between youth and age, gives Andromeda its characteristic appearance, it is a galaxy painted in contrasts. Young blue stars trace the spiral arms. Older red stars fill the central bulge and stretch across the disk, and as these colors blend and overlap, they create a mosaic that shifts subtly, depending on where you look. But of course, the galaxy is not made only of color. There are shadows too, vast and intricate regions where darkness cuts across the light. When we look at Andromeda through powerful telescopes, we see dark streaks threading through the bright disk. Dust lanes. These are clouds of interstellar dust, tiny particles suspended in space, absorbing and scattering visible light. These dust structures form silhouettes against the stars behind them, creating patterns of shadow that ripple through the spiral arms. They appear like smoke drifting across a glowing canvas, soft and mysterious. And, if you could float inside one of these dust clouds, you might not see anything remarkable. Dust grains are tiny, smaller than smoke particles on Earth. But collectively, spread across light years, they block the light of entire regions of the galaxy. They also carry the elements forged by dying stars, carbon, silicon, iron, materials necessary for planets and life. The dust is not merely an obstacle blocking our view, it is the raw material for creation. In many regions, the dust clouds swirl into shapes sculpted by radiation and gravity. In some, they form narrow lanes that cut sharply across the disk. In others, they form broad, soft shadows, dimming the light behind them. These regions, dark against the galaxy's brighter backdrop, tell us about Andromeda's internal structure as clearly as the light does. The shadows are part of the story, and the galaxy holds bright clusters too, places where starlight gathers in concentrated brilliance. Some clusters are composed of young stars, shining blue and fierce, while others are ancient globular clusters, groups of hundreds of thousands of old stars held together by gravity. These globular clusters appear as tiny, sparkling spheres scattered around the galaxy's halo. They orbit the galactic center like distant lanterns, each one older than almost any structure on Earth. And well, the contrast between these bright clusters and the dark dust lanes creates a richness, a texture, like highlights and shading in a painting. The galaxy comes alive not as a flat image but as a layered, three-dimensional structure. The bright central bulge seems to glow with a nearly white light, so intense is the combined radiance of the countless stars packed within it. Meanwhile, the outer regions shine more softly, their light infused with the cooler tones of older stellar populations. If you allow yourself to imagine drifting through Andromeda's disk, it becomes a landscape of light and darkness, brilliance and shadow. Blue stars flash like sparks along the spiral arms. Red stars glow like distant embers. Dust clouds weave between them like drifting fog. Globular clusters shimmer like jewels suspended in the halo. And the entire galaxy shines more brightly at the center than at the edges, its heart illuminated by the density of stars. This variation of light, from the bright inner core to the dimmer outer spiral, is not accidental. It reflects the distribution of mass, the age of stars, the galaxy's formation history. The center burns brighter because gravity has gathered more stars there. Older, redder stars dominate. The outer edges glow faintly because they hold fewer stars, more gas, more dust, and more room for change. And, this gradient is not unique to Andromeda, of course. Many spiral galaxies exhibit similar patterns. But in Andromeda, because of its size and mass, the gradient is especially striking. The core shines almost too brightly to look at directly. The disk, especially the outer arms, glows softly, steadily, and the halo fades into near invisibility, offering only occasional glints from globular clusters or tidal debris. And if you think about it long enough, you begin to feel something almost meditative in this distribution of light. It's as though the galaxy breathes, bright at its core, dim at its edges, alive with shades in between. The colors of Andromeda also tell us about its evolution. Blue hints at recent star formation, red whispers of ancient stars that have survived since the galaxy's earliest days. Dust shadows hint at regions where stars may someday form, and the bright clusters reveal areas of intense past activity. You see, light carries information. The color of a star tells us its temperature, its age, even its chemical makeup. The dust lanes tell us where the raw material of future generations lies hidden. The brightness profile reveals the structure of the galaxy. Light is the messenger of the cosmos, and in Andromeda's case, it is a messenger with many voices. Sometimes I imagine a future observer, perhaps a descendant of humanity, or perhaps a being from an entirely different lineage, studying the light of Andromeda long after the Milky Way and Andromeda have merged. What colors will they see? What remnants of this era will remain visible? Will traces of the blue star-forming regions linger in their new galactic home? Or will the stars blend together into new patterns, new motions, new waves of light? And well, as we ponder that idea, the thought naturally leads us towards something else. Because while the colors of Andromeda reveal its inner life, the interactions between Andromeda and the Milky Way shape its future. The faint distortions in the outer halo, the tidal streams, the subtle gravitational warping, all these hint that the two galaxies have already touched in gentle, ancient encounters. And so, gently carried by the light of young stars, old stars, glowing clusters, and drifting dust, we begin to drift toward the next chapter, the story of how Andromeda and the Milky Way have influenced each other long before their great collision arrives.